Hello students, welcome back to my channel. In previous lectures we have discussed about the motion of a vehicle along a curved path, what is centripetal, centrifugal force, and what is the well of death or wall of death. Now in today's lecture we are going to consider banking off-road. First you have to know what is meant by banking off-road. See, if you are traveling along a curved path, you have seen that the road at the outer edge is somewhat inclined, correct? Means some angle is made by the road with the horizontal, means there is some inclination with the horizontal. That is called as banking off road. That is, road is inclined at some angle with the horizontal. It is called as banking off road. Means the angle made by that inclined road with the horizontal, it is called as angle of banking. So question arises, why it is necessary? See, when we studied the motion of a vehicle along a horizontal curved road, what was that formula? That formula was V is equal to under root mu SRG. This was maximum set speed limit. V is equal to under root mu SRG. What is that mu S? Mu S is nothing but the coefficient of static friction. Means that centripetal force was provided by what? That is the static friction between the tires and the road. Correct? Means if speed increases, that friction also increases and there may be a tear and wear of the tires. So to avoid this, see, this centripetal force is provided by the friction and friction is at its higher limit. So tear and wear of tires, if we want to avoid, there is a remedy, that is angle of banking. If we make the road banked, that is some inclination with the horizontal, then normal reaction, component of normal reaction will provide the centripetal force, and it is possible to increase the speed without more friction, or there will be less friction between the tires and the road. So let us discuss what is this banking of road and what is the formula for angle of banking, that is theta. So for this we will discuss, we will consider one diagram. See, this is horizontal road. This road is inclined with the horizontal. See, this is horizontal plane, but road is somewhat inclined. That is, this angle is theta. This theta is called as angle of banking. Angle made by the inclined road with the horizontal. Now, one vehicle is here, correct, on that inclined. This theta is very small. It is not like this, but theta is small. Now we have to consider a PD for this. Okay, downward force exactly perpendicular to this horizontal, that will be weight force mg, correct. Now this is normal force acting on this vehicle by inclined road, correct. This was made 90 degrees. So this is normal force acting on this vehicle by this inclined road. So this mg must be get balanced, correct. For that I have to split this normal reaction into its two components. I will split this into two perpendicular components. Now if this is theta, if I take this diagram like downward, if I draw like this, if this is theta, this will be also theta, correct. Then this will be 90 minus theta and this will be again theta, correct. You are understanding this geometry? See, if this angle is theta, this is again theta, then this will be 90 minus theta and this will be theta. So the component adjacent to this theta, which is close to theta, we know that this is n cos of theta. The component which is close to this theta, it is adjacent to this theta, it is n cos theta, and the component which is perpendicular to that, like this, perpendicular component means this component, this is n sin theta. This is n cos theta, this is n sin theta. Now, this n sin theta will provide the centripetal force. This is the center of curved rod. This is the curved rod, correct? So, this is the center. Towards the center, this n sin theta is directed, means it is providing centripetal force required for the circular motion. So, centripetal force, what is the formula for centripetal force? It is mv square by r, correct? So, this n sin theta is providing centripetal force, means n sin theta is equal to mv square by r. Now, this n cos theta is get balanced by weight force mg. So, what I can write? I can write n cos theta is equal to weight force mg. Let this equation number 1, this is equation number 2. Divide equation 1 by 2. So, n sin theta divided by n cos theta is equal to mv square by r as it is, and divided by this mg, means there will be mg. N get cancelled, m get cancelled. What remains here? V square upon rg. And what is this sin theta upon cos theta? Sin theta upon cos theta is nothing but tan theta. So, tan theta is equal to V square upon rg. Therefore, theta is equal to tan inverse of V square upon rg. This is the formula for angle of banking, correct? Theta is equal to tan inverse of V square upon rg. If you observe this formula also, here there is no any term mass. The mass of the vehicle get cancelled. So this theta, angle of banking, is not depend upon mass of the vehicle. This theta is same for all the vehicles. It does not depend upon mass of the vehicle. What we have done? We have make the components of normal reaction which is acting on this vehicle, that is n cos theta, n sin theta. N sin theta is directed towards the center of the circular path. See, this is road, circular road, and this is the center of the circular road. So, this n sin theta is directed towards the center of the circular road, means it is providing centripetal force. Okay. See, when we are going to discuss this derivation, we are not going to consider the friction. Here we are not going to consider the friction. If we consider the friction, we can calculate upper and lower limit of the speed. That we will discuss in next part. But for this derivation only, we will consider n sin theta, n cos theta, these two components of normal reaction. Here, this n cos theta balancing weight force mg and n sin theta providing centripetal force. So, n sin theta is equal to mv square by r, n cos theta is equal to mg. If we divide this equation, we get tan theta is equal to v square upon rg. Therefore, theta will be tan inverse of v square upon rg. And this is the formula for angle of banking. And this angle of banking does not depend upon mass of the vehicle. There is a question on which factor theta is depends. So, you have to write which factor? Velocity, radius. On this factor, velocity of the vehicle and radius of the curvature, you can write. But if it is depend upon mass or not, no, theta is not depend upon mass. You understood the part which we have discussed today? We will discuss in next lecture, that is upper and lower limit of the speed, set speed. Okay. If you like my channel, share, subscribe and press the bell icon so you will get the notification about next lecture. And also I have told you that if you have any doubt regarding to this point or also any another point in the book, any numerical, you have any problem about that, you comment me in the comment box so that I will give the answer for that question. Okay, thank you.